This section covers the performance registers of the Coherency Manager. Within the global debug block is a set of registers you can use to get CM performance information. These registers are offset at hex 6000 from the starting address of the GCR. Here is an overview of the CM performance registers and their offsets. I'll go into each register in detail in subsequent slides. Performance characteristics of the CM can be measured via the 3 CM performance counters. There are two identical 32-bit performance counters that can be programmed to count CM-specific events, and there is an additional 32-bit cycle counter register. The counters are started and reset by using the bits in the performance counter control register. There are also bits in the performance counter control register that determine what to do on counter overflow. When a performance counter overflows, the corresponding bit is automatically set in the performance counter overflow status register. The overflow status bit is cleared by writing a 1 to this register. The event to be counted by each performance counter is designated by the event number set in the event select 0 and 1 fields of the CM performance counter event selection register. Each event is further specified by a corresponding CM performance counter qualifier register. With the CM performance counter control register, you can configure the behavior of the performance counters. If the performance counter interrupt bit is set, an interrupt is generated when any counter, including the cycle counter, reaches its maximum value of all Fs. The CM asserts the Coherency Manager program counter interrupt signal, which generates an interrupt only if the system integrator has connected the CM PC int to the SI-CM int of the System Interface Coherency Manager interrupt block. If the performance overflow stop bit is set to 1, then all CM performance counters will stop counting when any counter, including the cycle counter, reaches its maximum value of all Fs. If it is not set, then when the counter overflows, it rolls over and continues counting from 0. Setting the performance 1 reset, the performance 0 reset, or cycle count reset resets the corresponding performance counter register along with its corresponding overflow bit in the counter overflow status register prior to the start of counting. Setting performance counter 1 on, performance counter 0 on, or cycle count on starts counting of the corresponding counter. Reset bits and start bits can be set in the same access. This functionality allows all 3 counters to be reset and started with a single GCR write. The performance count number tells you the number of performance counters you have in the system. Currently, this will be set to 2. When a performance counter overflows, the corresponding bit is automatically set in the CM performance counter overflow status register. A status bit is cleared by writing a 1 to it. The event select register is divided into 2 parts for counter 0 and counter 1. There are 10 events that can be counted. Each of these events is further qualified by settings in the counter qualifier registers. Event 0 is the request count. It can be qualified by CPU or IOCU ports, cache coherency attributes, command requests, request length, and request target. It would be useful to use the request count along with the cycle count to get an idea of the request received over a period of time. Event 1 counts requests and responses to requests that can be identified by intervention states, speculative or non-speculative coherent cache read requests, and intervention command requests from a load or a store that missed in the L1 cache. Event 2 counts the write data bus usage, which is the number of cycles the L2 memory write data bus is in use. This event can be qualified to count stall cycles or not. Event 3 counts bus usage with the number of cycles the command data bus is in use. This event can be qualified to count stall cycles or not. Event 4 counts read data bus usage, which is the number of cycles the L2 memory read data bus is in use. This event can also be qualified to count stall cycles or not. Event 5 counts sharing miss, which is the number of cache misses that was satisfied by another processor. This event can be qualified by specifying which CPU should participate in the count. Event 6 counts response unit usage, which is the number of D words in the processor IOCU read data bus for a specific CPU. Event 8 counts L2 pipeline usage qualified by starts that was stalled, requests started and not stalled, waiting for sync to clear, request stalled, and request denied or request started. Event 9 counts L2 hit and misses. See the Software User's Manual for more information on the details of this count. Events 16 and 17 count IOCU requests. Different requests received by the IOCU can be qualified with a transaction ID, IO parking state, number of transactions in the request, burst length, L2 allocation type, posted or non-posted writes, cacheability, and by read or write requests. For further information, see the Software User's Manual section, CM Performance Counter Event Types and Qualifiers. These are the qualifier registers, one for each counter. These are used to configure the qualifiers for the events I discussed in the last slide. The qualifiers for some events are composed of several groups. A performance counter will increment if the specified event occurs and the qualifier criteria is matched in all groups. You should refer to the Coherent Processing System User Manual for your core for the specific qualifier values for each event. Here are the three counters and their offsets.